This on-demand training module for the deployment and initial configuration of SUSE Manager 4 will cover the product's architecture and how to do an online installation of a SUMA 4 server. There are three primary objectives to be accomplished with this module. First, I want to provide information on how the SUSE Manager 4 product is put together. By this I mean I'll discuss both the SUMA server side and managed client side architectures. Then I'll present the requirements that must be met in order to successfully install a SUSE Manager 4 server. The last objective in this module will teach you how to install a SUSE Manager 4 server when that server has a connection to the internet. This is referred to as an online installation. Let's start this module with a presentation of the architecture that underpins the SUSE Manager 4 product. The vast majority of our medium and large size SUMA customers implement their SUMA Manager infrastructure using a three-tiered architecture. Usually, this SUMA infrastructure will include a SUSE Manager server, some number of SUSE Manager proxy servers, and hundreds or even thousands of various servers that are managed clients. The SUSE Manager server is the overall controlling master of the SUMA universe. The SUMA server is the salt master and is generally a large physical or virtual server located in the organization's data center or even in a public cloud. The SUMA server is the piece of the architecture responsible for obtaining patch and update content from the SCC, maintaining its embedded database, which contains all things SUSE Manager related, such as patch metadata, inventory data, client configuration information, schedule actions, and so on. The SUMA server also provides a web-based management console along with command line tools for doing administrative, configuration, and reporting related activities. The SUSE Manager proxy servers are installed in an organization's remote office or campus locations. The purpose of the proxy is to offload work from the SUMA server in a large, geographically dispersed environment. Proxy servers are used to deploy new servers in the remote locations. Managed clients in those remote locations get their patch and update content from their local proxy server. The third tier of the SUMA architecture are the managed clients. These are the servers running SALT minion code that are either registered to the SUMA server via their local proxy server or directly to the SUMA server itself. The SALT master running on the SUMA server will send commands to be executed by the SALT minion code running on the managed clients. The SALT minion will return the results back to the SALT master. The diagram on this slide shows the high-level components running on the SUMA server and the managed client and how those components interrelate. Everything on this graphic, except the SALT minion and package manager code, is running on the SUMA server. In the next 4 slides, I'll define each component and its purpose that you see on this graphic. The SALT master is a daemon that runs on the SUSE Manager server. This is the configuration management server for all the SALT minions. The master will publish SALT commands on a communications channel that's called 0MQ, and the commands will be picked up and acted upon any SALT minions whose minion ID matches the target information specified in the command. Minions know the DNS name of their SALT master. When the master comes up, it provides a socket to which the minions bind in order to watch for commands. There is an initial handshake between the master and a minion. This handshake is how the master confirms that the minion matches the minion ID it is advertising. Inside the SALT master is a chunk of code known as manager_events. This code first appeared in SUMA during the 3.2.6 product release. This is a streamlined method by which SALT events get into the SUMA Manager's embedded Postgres database. Manager events intercepts SALT events from the SALT master and writes those events to the Postgres database. Then manager events will leverage the notify feature of Postgres in order to let Tomcat know that some new event needs to be processed. Tomcat reacts to SALT events that are the results of SALT minions executing commands issued from the SALT master. The XML RPC API is implemented in Tomcat and is used by the SpaceCMD command line utility as well as others. The SUMA Web UI is also implemented in Tomcat. The Web UI is the SUSE Manager's web-based management console tool. After installing the SUMA server and going through an initial configuration process, this configuration process, when it ends, will display the URL that can be used to access the Web UI from a browser. The SALT application programming interface serves as a connector between Tomcat and the SALT master and between the Task-O-Matic process and the SALT master. The Task-O-Matic process is like a combination of the Linux cron and at commands. Its purpose is to trigger activities that are supposed to run at a particular time or at some regular interval. There are several processes that Task-O-Matic will initiate, such as syncing repositories from the SCC, determining which patches and updates should be applied to a particular SALT minion, kicking off schedule actions, and periodically it will do a SALT ping to all the SALT minions, and it does a host of cleanup types of activities. The PostSQL embedded database contains all the data handled by the SUMA server. The database contains all manner of information, such as those listed here on this slide. The SALT minion is the client-side agent running on the managed device. Each SALT minion has a unique ID. It's this ID that serves as the target information when the SALT master issues a command. After the command has been executed by the SALT minion, the results are sent back to the SALT master and ultimately end up as events in the PostgreSQL database. The 0MQ, and a lot of times you'll see this written simply as 0 capital M capital Q, is the communications bus between the SALT master and all of the minions. 0MQ is an open source messaging library that is designed to connect the disparate parts of a distributed system. 0MQ provides support for more than 20 different programming languages. When the SALT master sends out a command over 0MQ, it is said to publish events. All minions subscribe or listen to the 0MQ bus, but it will only act on a command if the minion's ID matches the target information in the command. When a SALT minion receives a command to install or update some package, it's the job of the package manager on the managed device to retrieve the RPM packages from the repositories dished out by the Apache 2 web server. When the RPM package has been downloaded from the repo, it will be installed on the managed device by the package manager. For SLES and OpenSUSE-based minions, the package manager is Zipper. SUMA uses other open source technologies as well. Cobbler is used for bare metal deployments of an operating system down to a target device. Cobbler will leverage AutoYast and Kickstart profiles for OS distributions that can be auto-installed. These auto-installed OS deployments will require PXE, and SUMA uses Cobbler to manage the PXE configuration. Kiwi is a command line tool written in Perl that is used to build Linux OS images in any number of supported formats. A SALT minion can be designated to also be a build host. Designating a SALT minion to be a build host will cause certain Kiwi-related packages to be installed on that minion. The build host will interface with Kiwi to create SALT boot images according to the configuration of your image profile that you create with the Web UI. SUSE Manager 4 still provides support for two distinctly different types of clients, the SALT client and what we call the traditional client. Prior to SUMA 3, traditional clients were the only type of client we had because our traditional client predated the SALT OpenStack project. To support traditional clients, we use an open source technology known as XMPP, which used to be called Jabber. And Jabber performs many of the same things that 0MQ is used for in the SALT world. The main components for a traditional client are the RHNSD and OSAD, simply referred to as OSAD, components which originated with the Red Hat Network Satellite product. It's very important to note, though, that all of our development cycles for SUMA go toward the SALT architecture. We will not be adding any new features or capabilities to the traditional client. Therefore, any new clients added to an existing SUMA environment should be SALT minions. This objective will teach you the hardware and software requirements that must be met in order to successfully install a SUSE Manager server. Before you begin your installation process, you need to go to the product download URL shown on this slide and download the SLES 15 SP1 Media Installer. This ISO contains the new unified installer that will install the SLES 15 SP1 OS and any of the available extensions and add-on modules, such as the SUSE Manager 4 server or a SUSE Manager 4 proxy server. When using the unified installer, you can either do an online or a disconnected installation of SUMA 4. This module presents the online installation. In order to complete an online installation, the server on which you want to install SUMA 4 must have internet access and be able to resolve the DNS names scc.suse.com and updates.suse.com. And you must have your organization's SCC, SUSE Customer Center, account and password information. In another module, I'll present doing a disconnected installation of SUMA 4. You should take care when choosing the host name for your SUMA 4 server. While it is possible to change the host name of a SUMA 4 server after the installation and configuration process has been completed, it is not supported by SUSE. This slide shows the hardware requirements for a SUSE Manager server. You should meet these requirements regardless of whether you are running a physical or virtual server. Notice that the minimum amount of RAM for a SUMA server used in production is 32 gigabytes of RAM. Plus, you need to run on servers that have multiple core CPUs, with 4 CPUs being a minimum for a production server. The amount of disk space that your SUMA server will require is directly linked to the number of different products for which you want to provide patches and updates. For every SUSE product you will be supporting, allocate a minimum of 50 gigabytes of disk space. And if you are supporting Red Hat Enterprise servers, you should count on at least 250 gigabytes for each version of RHEL. Also note that we have some best practices shown here on this slide regarding the partitioning of your SUMA server's drives. This slide shows the ports that should be opened on the firewall on your SUMA server for inbound traffic. Ports 5222, 4505, and 4506 are important for communications between the SUMA server and traditional clients, and between the SUMA server and SALT minions that are being managed by SUMA. Here you see the minimum outbound ports that you must have open in the firewall of your SUMA server. SUMA 4 can be used to manage SLES 11x, 12x, and 15x servers. SUSE will provide support for these OS platforms as either SALT minions or traditional clients, provided one of the following conditions is met. Either the OS platform in question is still under SUSE general support, or if the OS platform is no longer under general support, then your organization must be able to support the target OS platform under our Long-Term Service Pack Support Program, LTSS. For instance, general support for any version of SLES 11 ended in March of 2019. However, you can still buy LTSS support for SLES 11 until March of 2022. So if you still have SLES 11 SP4 servers, let's say, that you want to manage via SUMA 4, SUSE will provide SUMA 4 support for that OS platform if your organization has an LTSS for SLES 11 SP4. Also, SUMA 4 supports RHEL 6 and RHEL 7 as either a traditional client or a SALT minion. Remember that all client-side development, however, will happen only under the SALT architecture. The final objective of this module will lead you completely through the process of doing an online installation of the SUSE Manager 4 server. Along the way, I'll work in some tips and best practices that you will want to keep in mind when installing your own SUMA 4 servers. After downloading the SLES 15 SP1 Media Installer from our download site, you can use that ISO to directly boot up a VM to begin installing SUMA 4, or burn the ISO to DVD and use it to boot up a physical server. The process described in this objective will install both the SLES 15 SP1 OS and SUSE Manager Server version 4. It is important to understand that having an existing SLES 15 SP1 server and then installing SUMA 4 after the fact is not a supported installation method. Although it is possible to do this, it is not supported because this will cause some symbolic links to get pointed to the wrong files and directories, which will cause you problems if you later try to upgrade the OS or SUMA Manager itself. The only supported manner in which to install the SLES 15 SP1 OS and SUMA 4 is via the Unified Installer. Once you've booted up from the Media Installer, the Unified Installer will automatically start. Cursor down to highlight Installation. You can then press Enter to begin installing the OS and SUMA 4, or you can type in boot options and their values as shown on the next slide. In this example, I'm doing an online installation of this server, so therefore I need to be able to contact the SCC. To facilitate configuring the network addressing required to allow this server to contact the outside world, I like to specify some boot options that will provide all the addressing needed to contact the SCC. The bubble on this screenshot shows in red the boot options I specified and their value. These boot options are used to specify the following addressing information: the IP address and subnet mask of this server using CIDR notation, the address of the gateway this server should use, the address of 2 DNS servers, one of which needs to be capable of resolving scc.suse.com and updates.suse.com, and the domain name to be used for this server, which in this example is example.com, and lastly, the fully qualified domain name, FQDN, of this server, which in this example is suma4-dev.example.com. After typing in these boot options, pressing the Enter key will start the installation of SLES 15 SP1 using the IP addressing supplied via the boot options. After specifying the desired boot options and pressing Enter, you will see the next two screens shown here. Notice that the option for SUSE Manager Server 4.0 is selected on the Language, Keyboard, and Product selection screen on the left. After selecting SUSE Manager Server 4.0 and selecting Next, the SUSE Manager Server 4.0 License Agreement screen is displayed. The registration screen is displayed after the SUSE Manager 4 License Agreement. The default selection on this screen is for an online installation of the SUMA 4 server. With Register System via scc.suse.com selected, you will need to ensure that your server can access the internet and that you have your organization's SCC credentials handy. The Register System via Local SMT Server option is used when doing a disk-connected installation of SUMA 4. No internet connection is required by the SUMA 4 server in this case. However, you must have a local DNS capability to resolve the URL that points to your internal SMT or RMT server. If you didn't specify the boot options necessary for configuring your server's IP addressing needs, you can use the Network Configuration button you see here in the upper right of this graphic to provide the required IP addressing information. This screenshot shows how the information I provided by the boot options back on the first installation screen have populated the various tabs of information shown here on the network settings screen. Providing the boot options allows this screen to be completely bypassed. It is shown here to show the impact of applying the boot options that were entered back on the first installation screen. Selecting Next on the registration screen will display a dialog box where you are prompted to update the repositories from the SCC. Once you respond to that update dialog, you will cause the extension and module selection screen to be displayed. Note the default selections. These selections are due to selecting SUSE Manager Server 4.0 back on the language keyboard and product selection screen. After the extensions and module selection and add-on product screens, you'll see the system role screen shown in this screenshot. There are two new options on this screen for SUMA 4, SUSE Manager Server and SUSE Manager for Retail Server. These system roles will cause certain patterns to be installed and suggest a partitioning scheme for the server's drives based on our best practices. As a side note, choosing the SUSE Manager for Retail Server role will also install the SUSE Manager Server related code, because Retail is built on top of SUSE Manager. The suggested partitioning screen shown here displays the recommendations the Unified Installer makes for how the server's drives should be partitioned based on your choice on the system role screen and the server's drive configuration. You can either click Next to accept the partitioning recommendations or click the Expert Partitioner button to modify what is suggested. In this example, the Expert Partitioner button was clicked on the previous suggested partitioning screen. The reason the suggested partitioning is modified in this case was that the /var/spacewalk and /var/lib/pgsql partitions were not defined to be LVM value. And it does make sense to use LVM for these two partitions if you suspect that additional OS platforms will need to be patched or updated at some point in the future, because LVM makes it easy to add additional disk space to existing volumes as needed. In this example, the volume group SCC-content contains a logical volume named spacewalk, and that logical volume is mounted on the /var/spacewalk directory as an XFS file system. The volume group SUMA-metadata contains a logical volume named PGSQL, and that logical volume is mounted at the /var/lib/pgsql directory, also as an XFS file system. This screenshot depicts the suggested partitioning screen after making the LVM-related changes in the Expert Partitioner. You can see here that the SUMA metadata volume group will be created on the /dev/SDC drive, and that the SCC-content volume group will be created on the /dev/SDB drive. Clicking Next on this screen will display the clock and time zone screen, and this is where you can configure NTP for your SUMA server, and the local user screen, where you create the SUMA server's first non-root user, and the authentication for system administrator root screen, where you assign the root user's password on the SUMA server. The installation settings screen depicted here is the last screen where you can make changes to how your SUMA server will be installed. There are a couple changes on this screen that you may wish to make. Under Network Configuration, you see Using Wicked. Using the Wicked service for network configuration allows you to use YAST to modify the network settings of your SUMA server. The other option here is to use Network Manager for network settings. If you choose this option and then go into YAST, you will not be able to modify most of your network-related settings, and you will be told by YAST that you need to use Network Manager. Then under Default System D Target is where you determine whether or not your SUMA server will have a GUI desktop. By default, it does not in SUMA 4. But if you change text mode to graphical mode, and then select the X11 packages for installation under the software heading, which is above the network configuration section on this screenshot, your SUME server will have a GUI desktop environment. After clicking the Install button on the previous installation settings screen, the installation process will get started. Once it has completed, the SUME server will be automatically rebooted. But you will still have the SUME server configuration process to complete before you can start managing client servers. The module on Setup of SUME 4 will take you through the necessary configuration process.